Namaste children. Today we are going to discuss the first chapter, rational numbers. So this rational numbers chapter you are already familiar in class 7th, chapter number 9. So what we are going to discuss in class 8th, rational numbers chapter. First concept is introduction of the chapter, then properties of rational numbers, then representation of rational numbers on the number line, finding rational numbers between two rational numbers. So the four concepts are there. The major concept of this chapter is properties of rational numbers and its applications. So now come to class 7th. What we studied in class 7th? What are rational numbers? What is the necessity to find rational numbers? How do we represent rational numbers on the number line? Standard form of rational numbers, lowest form or simplest form of rational numbers, and the last concept is this, the arithmetic operations of on rational numbers, that is addition of rational numbers, subtraction, multiplication and division of rational numbers. We have covered in class 7th. Now we have a small revision of class 7th, what we discussed under introduction will finish. Then we will go for the properties of rational numbers. Then we will continue the other topics. So introduction of this chapter. So rational numbers, they are also numbers. So the numbers are made up of digits. The numbers are made up of digits. As you know, the digits we have, how many digits are there? 10 digits are there. There are 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. These are known as digits. So all the numbers are made from these digits. So the first kind of numbers which we studied is the natural numbers. Natural numbers are also known as what? Counting numbers. They are also known as counting numbers. Natural numbers are represented by the first letter of their name, that is n. So the set of natural numbers or the counting numbers which are used for counting are, they starts with 1, 2, 3, 4 and so on. So these numbers are known as natural numbers. The first, least and smallest natural number is 1. There is no the largest natural number or the biggest natural number because there is no end. And we got as infinity. Right. Now the second set of numbers are known as whole numbers. So the whole numbers are represented with their first letter, that is W. So set of the natural numbers are set of whole numbers. Whole numbers are the numbers including natural numbers and 0. Natural numbers are 0. That is 0, 1, 2, 3, 4 and so on. So these kind of numbers are known as whole numbers. Next, the third type of numbers are known as integers. And they are also known as Judaic numbers. So integers are represented with a letter called Z, or even we will represent with I. We also represent with I or the letter Z, integers. So what are integers? Integers are a set of numbers, that is whole numbers, including negative numbers. Whole numbers including negative numbers we studied. That is 0, 1, 2, 3, 4 and so on. On the right side of 0. Left side of 0 we have -1, -2 and -3 and so on. So infinity negative numbers are there and infinity positive numbers are there. 0 is neither positive nor negative. So all these things we studied in class 7, the integers chapter. Then rational numbers also we have studied in class 7th. The next type of numbers are known as rational numbers. rational numbers. Rational numbers are represented with a letter called Q. Q stands for quadratic numbers. Q stands for Q came from the other name of rational numbers. It is quadratic numbers Q. So what are rational numbers? The numbers which can be expressed in the form of P by Q, where P and Q are integers. P and Q are integers and Q is not equal to 0 are known as rational numbers. So rational numbers are the numbers which can be expressed in the numbers which can be expressed in the form of P by Q. In the form of P by Q, where P comma Q are integers. They belongs to integers. This is the symbol belongs to. So P and Q both are integers and Q is not equals to 0. Q is not equal to 0. Such numbers are known as rational numbers. Such numbers are known as rational numbers, and we have studied in detail about the rational numbers in class 7th. That is, some of the examples of rational numbers. You can take all natural numbers are rational numbers, all whole numbers are rational numbers, all integers are rational numbers. It means natural numbers, whole numbers, integers, all can be expressed in the form of P by Q, where P and Q are integers and Q is not equal to 0. That's why all those numbers are also integer, rational numbers. Other than this, we have fractions are there and decimals also are included in the rational numbers. So this is about the introduction of this chapter, rational numbers. So the first topic is introduction. Then we will continue the properties of rational numbers. Is it clear, children? Now we will continue the second topic, that is properties of rational numbers. So before we are going to discuss properties of rational numbers, let us recall the properties of whole numbers and integers also. Together, whole numbers, integers and rational numbers, we will study the properties under the 4 arithmetic operations, that is addition, subtraction, multiplication and division. Under 4 arithmetic operations, we will discuss with one example each whether the property is satisfied or not. So what is the closure property statement? Under addition, under subtraction, under multiplication, under division, we have the same statement. If it is addition, the sum of 2 whole numbers is also a whole number. If we are to consider integers, the sum of 2 integers is also an integer. Similarly, for rational numbers, the sum of 2 rational numbers is also a rational number. If that statement is satisfied, then we can say that whole numbers are closed under addition, rational numbers are closed under addition, or closure property is satisfied by whole numbers or integer or rational numbers under addition. So similarly, we can also discuss for subtraction, multiplication and division also. Now, first discuss whole numbers. The first property, closure property. So what the statement for closure property for whole numbers? Let A and B let A and B are 2 whole numbers. A and B are 2 whole numbers. Then A plus B is equal to C. Then A plus B is equal to C, and C is also a whole number. Here A and B are 2 whole numbers. When we added, the result C is also a rational number. A plus B is equal to C. Here what are A, B and C? They are whole numbers. If we consider integers, they are integers. If we consider rational numbers, they are rational numbers. So in general, I am taking A, B, C are 3 numbers. If they are whole numbers, they are whole numbers. If they are integers, they are integers. And if they are rational numbers, they are rational numbers. So in general, the sum of two whole numbers is also a whole number. We will see whether it is satisfied for whole numbers or not under addition. Yes. So a plus b plus c. A plus b is equal to c. Take two whole numbers 2 and 3. 2 plus 3 is equals to 5. 5 is a whole number or not? Yes, 5 is a whole number. That is, by adding two whole numbers, the sum is also a whole number. Therefore, it is satisfied. So, what is satisfied? Closure property is satisfied by whole numbers under addition. Simple way I am explaining. Then we will discuss for whole numbers under subtraction. That is, the difference of two whole numbers. The difference of two whole numbers is also a whole number. That is, a minus b is equals to c. A minus b is equals to c. We take two examples. 3 minus 2 is equals to 1. 1 is a whole number. For this example, it is satisfied. There are, so if you consider one more example, let a is equals to 4 and b is equals to 5. 4 minus 5 is equals to what? Minus 1. 4 minus 1 is equals to what it is? Minus 1, which is not a whole number. Minus 1 is not a whole number. Therefore, what we can say? Closure property is not satisfied by whole numbers under subtraction. So, we can write this not satisfied. Not satisfied. Not satisfied. So, whole numbers satisfies closure property under addition but not under subtraction. Now apply the same concept for multiplication. Let a, b are two whole numbers, then their product is also a whole number. A into b is equals to c, where a, b and c are whole numbers. Take any other example. Let a is equals to 3 and b is equals to 2. 3 into 2, 6. It is a whole number. You take some other example. Let a is equals to 5 and b is equals to 10. 5 into 10, 50. This is also a whole number. That means the product of any two whole numbers is always a whole number. So we can conclude that the closure property is satisfied by whole numbers under multiplication. Therefore, it is satisfied. It is satisfied. Closure property is satisfied under multiplication. Then we will discuss for division. Let a and b are two whole numbers. Then a divided by b is equals to c. A divided by b is equal to c, where c is also a whole number. Example take 4 divided by 2 is equals to 2. 2 is a whole number. So it is satisfied for that example. We will consider one more example. Let a is 2 and b is 4. 2 divided by 4 means 2 by 4. That is 1 by 2, which is not a whole number. 1 by 2 is not a whole number. We will not find 1 by 2. 1 upon 2 is not a whole number. Therefore, closure property is not satisfied by whole numbers under division. Not satisfied. It is not satisfied. Closure property is not satisfied by what? Whole numbers under division. Under division. The statements are similar for whole numbers, integers and rational numbers. Now we will discuss integers. The second set of numbers, integers. Yes, integers. So here also we are considering the two numbers a and b, and those are integers. For integers we consider a and b are integers. Their sum is also an integer. You see here. Let a plus b, a and b are two integers and their sum is also an integer. Take an example. 3 plus 2 is equals to 5. It is an integer. 3 plus minus 2 is equals to 1. It is also an integer. Minus 2 plus minus 3 is equals to minus 5. It is also an integer. So we can conclude that the sum of two integers is always an integer. The sum of two integers is always an integer. So we can conclude and we can say that the integer satisfies closure property under addition. Now the second, that is under subtraction discuss. Let a and b are two integers, then a minus b is equal to c, where c is also an integer. We will find out now. So 4 minus 3 is equals to 1. It is an integer. 4 minus 3 is equals to 1. It is also an integer. 4 minus 3 is equals to 4 minus 3 is equal to 7. It is also an integer. It is also an integer. You take any number of integers. Minus 4 minus half minus 7 is equals to, by subtracting minus 7 from minus 4, we get 3. 3 is also an integer. Therefore, integers satisfies closure property under subtraction. So it is satisfied. This is satisfied. Under addition also it is satisfied. Addition also it is satisfied. Now we will discuss multiplication. Under multiplication, let a and b are two integers, then a into b is equals to c, where c is also an integer. You take this 3 into 2, 3 2s are 6. 6 is also an integer. Next you take minus 3 into 2 is equals to minus into plus is minus 3 into 2, 6. Minus 6 is also an integer. 3 into minus 2, that is also equals to minus 6. That minus 6 is also an integer. So from this what we can say, take any two integers and you multiply, the product is also an integer. Hence we can conclude that integers satisfies closure property under multiplication. So it is satisfied. It is satisfied under multiplication. Now we will discuss what under division. So here, let a and b are two integers, then a divided by b is equal to c, that c is also an integer. You take an example. 4 divided by 2 is equals to 2. It is an integer. It is an integer. Minus 4 divided by 2 is equals to minus 2. It is also an integer. When we divide minus 4 with 2, the quotient is minus 2. Minus 2 is also an integer. Now you take, divide minus 4 with 8. Then what we get? Minus 4 divided by 8. We will get it as minus 1 by 2, which is not an integer. Minus 1 by 2 is not an integer. Therefore, it is not satisfied. It is not satisfied. It is not satisfied. Which is not satisfied? Closure property is not satisfied by integers under division. So integers satisfies closure property under addition, subtraction and multiplication. Whereas whole numbers, they satisfies this closure property under whole numbers and under addition and multiplication only. Is it clear, children? Now we will discuss the closure property for rational numbers under 4 arithmetic operations. So rational numbers. Let a and b are two rational numbers, then their sum, that is c, is also a rational number. We will see with some examples. 2 plus 3, 2 and 3 both are rational numbers. 2 plus 3 is equals to 5. 5 is also a rational number. Now we take 1 by 7 plus 2 by 7. By adding, both are rational numbers. 1 by 7 plus 2 by 7 is proper fractions. 1 plus 2 it is 3. 3 by 7, that 3 by 7 is also a rational number. Like this, you take n number of, that is any two rational numbers, their sum is also a rational number. Their sum is also a rational number. Therefore, it is satisfied. So, closure property is satisfied by rational numbers under addition. What about the subtraction? Subtractions we will see. Let we take 2, that is let a comma b are two rational numbers, then A minus B is equal to C. That is also a rational number. C is also a rational number. Take an example. A is equals to 2 minus B is equals to 3. 2 minus 3 is equals to minus 1. The result is also a rational number. It is satisfied. Now we take 4 by 5 minus 2 by 5. 4 by 5 minus 2 by 5 like fractions. So we will subtract the numerators. 4 minus 2 it is 2. 2 by 5. The 2 by 5 is also a rational number and it is satisfied under subtraction. Then multiplication. Let A comma B are two rational numbers. Then A into B is equal to C. Let A comma B are two rational numbers. Then A into B is equal to C. That is the product of two rational numbers is also a rational number. See examples. 2 and 3 both are rational numbers. 2 into 3 6. 2 into 3 it is 6. Next you take minus 2 into minus 4. You will get 8. That is also a rational number. Now you take in the form of fractions. 2 by 3 into 4 by 2 by 3 into 4 by 5. So how do we multiply two fractions or two rational numbers? Multiply the numerators. 2 into 4 it is 8. Divided by 3 into 5 it is 15. 8 by 15. This 8 by 15 is also a rational number. That is, the product of any two rational numbers is also a rational number. Hence, it is satisfied. It is satisfied. So, subtraction also we have seen it is satisfied. Now, what about division? So, division, closure property under division. Let you take two rational numbers. Let A comma B are two rational numbers. Then A divided by B is equal to C is also a rational number. Is also a rational number. A comma B are two rational numbers. Then A divided by B is equal to C is also a rational number. You see here. We'll see. Let A is equals to 4 divided by B is equals to 2. We will get 2. 2 is a rational number. Let A is equals to 5 and B is equal to 7. 5 divided by 7, that is 5 by 7. It is also a rational number. It is also a rational number. Now we take let A is equals to 1 and B is equal to 0. That is 1 by 0. It is not a rational number. 1 by 0 is not a rational number. Why? Because Q is equal to 0 we got here. What is the rational number? The numbers which can be expressed in the form of P by Q. The numbers which can be expressed in the form of P by Q, where P and Q are integers and Q should not be equal to 0. But here Q we got 0. Therefore, this is not a rational number. For these two examples it is satisfied and for this example it is not satisfied. Therefore, what we can say, rational numbers does not satisfy closure property under division. They do not satisfy closure property under division. That is not satisfied. Not satisfied. So like this, we can discuss the property of closure property under all the four arithmetic operations for the three types of numbers: whole numbers, integers and rational numbers. Here, whatever the type of numbers it is, statement is common. Closure property, if we consider addition, sum of two integers is an integer, sum of two whole numbers is a whole number, sum of two rational numbers is also a rational number. Subtraction, the difference of two rational numbers is a rational number, the difference of two whole numbers is a whole number, the difference of two integers is an integer. Similarly, for multiplication, the difference of two rational numbers is, so the product of two rational numbers is a rational number, the product of two whole numbers is a whole number, the product of two integers is an integer. So under division also, that is what it is, when we divide a whole number by another whole number, we will get what? The quotient, it should be a whole number if it is satisfied. Similarly, integers and the rational numbers also. So like this, we will study the properties of all the types of rational numbers with common statements in the form of a tablet and some examples. Is it clear, children? So today we discussed introduction of this chapter and properties of rational numbers. Under that, the first property we studied closure property for all the three types of numbers. I hope you understand and thank you very much.